Right, let's have a look here. So I want to start off with find the average velocity first. So the average velocity would be, and that's the position. So um, the velocity is the derivative. And to get the average, you integrate 0 to 2 pi, one period, 1 over 2 pi. And then the derivative here is minus a omega sine omega t minus phi dt. So that's going to be 0. But what's a little bit more interesting is the average speed. So that would be, just to be clear about the formula, that'd be 1 over 2 pi, 0 to 2 pi, the the absolute of the velocity. And just remember that the velocity is dx dt. Because you could use the fundamental theorem of calculus here. So it actually equals 1 over 2 pi a cos omega t minus phi 0 and 2 pi. Oh, sorry, it's not. No, I'm sorry, it's not 2 pi. The periodic time is 2 pi over omega. So there should be an over omega here. Yeah, there we go. There we go. So again, I'm missing my over omega here. So that would be, you could do this as omega over 2 pi times 2 and just integrate over the positive region, but then multiply by a half because the graph looks like this, I think. So what I'll do is I'll just integrate a omega sine omega t minus phi dt, and I have to choose limits so I can go over well, actually, because the phi, it won't start at 0. So the difficult part here is choosing the limits so I can get one period. So I want omega t0 minus phi to equal 0. So that means t0 will be phi over omega. And then t1, omega t1 minus phi equals pi. So that would be pi plus phi over omega. Well, those twos cancel at least. So that's omega over pi. And then integrating that, we'd get minus a cos omega t minus phi with the limits phi over omega and pi plus phi over omega. So if I put the first one in, that's minus omega over pi, and then omega times that would be phi, so it'll just be cos phi minus cos 0. And cos phi is minus 1. That's minus omega over pi. And then that's minus 1, isn't it? And then cos 0 is 1, so it's minus 2. So that's 2 omega over pi. And I feel like I've lost an a or something somewhere. Maybe I did lose an a. Which, funny enough, actually equals that's the answer, but I just want to show you something here. Oh yeah, I never actually said the first one is 0. Sorry, 0. That's the answer. But I just want to show you something here. This equals 4a over 2 pi over omega, because the 4 and the 2 cancels to make 2, and the omega comes up at the top, which is actually the total distance over the total time. So that works out perfectly fine then. The average displacement, well, the average displacement is going to be the same deal as before. It's going to be omega over 2 pi 0 2 pi over omega the xt dt, and because of the cost nature of it, it's going to work out as 0. And the average distance from rest, so that's kind of the tricky one again, because the distance requires the modulus. So that's going to be a little bit tricky. So for the average distance, we can do the same trick as before. So that would be 2 omega over 2 pi, phi over omega, phi plus omega plus phi, pi plus phi over omega, and it's the absolute. So I'll just look at the positive region, integrate over that, and double the answer. So here's the x here. When is that positive? So for cos, I should change the limits. I can go not quite the same limits. I want to try and get to pi over 2 and minus pi over 2. So it'd be pi over 2 plus phi over omega, and pi over 2 minus pi over 2 plus phi over omega, a cos omega t minus phi dt. So again, the 2's cancel. That's omega over pi a sine omega t minus phi with the limits. Phi minus pi over 2 over omega, and phi plus pi over 2 over omega. Okay, so if I put that one in, the omegas cancel and the phi's cancel. It's just sine pi over 2, which is 1. So it'll be 2 then. So it'll be 2 omega a over pi. No, that seems wrong, because I forgot when I integrate to divide by omega. So the omegas actually cancel out. So it's just 2a over pi. Okay. Average velocity, average speed, average displacement, and average distance. Yeah. So let me think. Could I have gotten the average distance another way? I think I could have. Let me just show you. If we use our distance, speed, time triangle, you could have said that the average distance is the average speed, which is 2 omega a over pi, multiplied by the time, which is 2 pi over omega. So the pi's cancel, the omegas cancel, and that's oh, but that's not the average distance. That's actually the total distance. So that doesn't work. 2a over pi. I'm not sure. That's the only the last one I'm not 100% confident on. The average velocity being 0 definitely seems right to me. And the average speed being 4a over 2 pi over omega. So that's 4 omega a over 2 pi or 2 omega a over pi. So that seems good as well to me, as does the average displacement. So it's just this last one. I just want to make sure I'm right on it. Um, uh, I just, uh, I just feel like I should have a root 2 in it, maybe. Um, it's the 2 that's surprising me a little bit. I just felt like there should be a root 2 in it. Um, hmm, um, sine pi over 2 is 1. Yeah. Let me pause the video and check the answer somewhere online. When I use my algebra software, I get a over pi. So yeah, I was right to be suspicious of the 2. So something's gone a bit fishy with the 2. So um I have the wrong limits here. Actually, no, it doesn't really matter because it's still one period. So I think that's right. Then I divide by the 2. But I get the 2 here because the sine pi over 2 minus sine minus pi over 2. That's, so what's gone wrong? 2, maybe it's maybe I did something wrong here. So that's the cosine function. Oh, that integration is wrong because I don't need to compensate because I have the absolute symbol in it. So this is wrong. It's actually should be minus pi to pi. And then I multiply this by omega over 2 pi. 2a over pi. Yeah, okay. Okay, so it looks like those 4 answers are correct.